Hello viewers, in today's class we are going to discuss three very important problems from application of derivatives related to rate of change of quantities, right? So let us start. So here we have the first problem. The median of an equilateral triangle is increasing at the rate of 2 times square root of 3 centimeters per second, and we have to find the rate at which its side is increasing, right? So here we are given an equilateral triangle. So here let us take an equilateral triangle. This is the triangle A, B and C, right? And here we are given the median of the equilateral triangle. So let us draw the median like this, and let us take this point as D, right? Now see, we know that in equilateral triangle all the three sides are equal, and moreover the altitude and the median of the triangle coincide, right? Or in other words, we can say that the altitude and the median of an equilateral triangle are same, right? So here let us take the side of the equilateral triangle as x. So this is x, and since AD is the median, so here BD is x over 2, DC is also x over 2, right? And here we have the angle that is 90 degrees. So now let us take the length of the median AD as m, right? And now we can apply the Pythagoras theorem for triangle AD and C, right? So here the Pythagoras theorem goes like this, that is AC square, that is the square of the hypotenuse, is equal to the sum of the square of the base, that is DC square, and the square of the perpendicular. So here we have AD square, right? So AC square is x square, DC is x over 2 square, and AD square is m square, right? So now m square can be written as x square minus x over 2 square, taking this term to this side. So we have x square minus x square over 4, and we have 4x square minus x square over 4, that is 3x square over 4. So m can now be written as square root of 3x square over 4. So we have now root 3 over 2x, right? So the length of the median of an equilateral triangle whose each side is x is given by square root of 3 over 2 times x, right? So here we have derived the length of the median in terms of the length of the side, right? Now see, here we are given that the median of an equilateral triangle is increasing at the rate of 2 times square root of 3 centimeter per second, right? So we are given dm over dt is equal to 2 root 3 centimeters per second. So what we will do, we'll differentiate this equation 1 with respect to t, right? So differentiating both sides with respect to t, because we have to find the rate of change of median, right? So we have dm over dt, and here we have root 3 over 2, and this is dx over dt, right? Now dm over dt, that is rate of change of the length of the median with respect to time, is 2 root 3. So here we can write 2 root 3, and here we have root 3 over 2 and dx over dt, right? Now dx over dt can be written as 2 root 3, taking this 2 to this side, multiplying it 2 root 3 multiplied by 2 divided by root 3. So root 3 and root 3 get cancelled. So we have dx over dt is equal to 4, and the units are centimeter per second, right? So dx over dt represents the rate of change of the length of the side of the equilateral triangle with respect to t, right? And this is what we have to find out. So find the rate at which its side is increasing, right? So the rate of change of the length of the side of the equilateral triangle is dx over dt, and dx over dt is positive 4 centimeter per second, right? So the side is increasing with the rate 4 centimeters per second. Now let us take the second problem. So here we have to find an angle which increases twice as fast as its sine, right? So here what we will do, we'll take the angle as say x, right? So we have to find an angle which increases twice as fast as its sine, right? So the rate of change of the angle with respect to time is given by dx over dt, right? So dx over dt is the rate of change of the angle with respect to time, right? And here we are given find an angle which increases twice as fast as its sine, right? Now the sine of the angle x is given by sine x, right? And the rate of change of sine x is given by d by dt of sine x, right? So dx over dt is the rate of change of the angle x, right? And d by dt of sine x represents the rate of change of sine of x, right? So here let us read out the question one more time. So here we have find an angle which increases twice as fast as its sine. So dx over dt must be equal to 2 times the derivative of sine x with respect to t. That is the rate of change of sine x with respect to t, right? So here we have to form this equation, right? So now let us find out the derivative of sine x with respect to t, right? So here we make use of the chain rule. So what we will do, dx over dt is equal to 2 times. First we'll find the derivative of sine x with respect to x, and then by chain rule we have dx over dt, right? Now the derivative of sine x with respect to x is cos x, so we have 2 cos x, and here we have dx over dt, and here also we have dx over dt, right? Now dx over dt and dx over dt get cancelled, so here we are left with 1. So we have now 1 is equal to 2 cos x, right? So this is a trigonometric equation. So cos x is now equal to half, and we know that cos 60 degrees, that is pi by 3, is equal to half, right? So cos 60 degrees is equal to half. So now cos x is equal to half implies that cos pi by 3. So the value of x should be equal to pi by 3, right? So this is how we can solve this problem number 2. Now let us take the problem number 3. So here we have the problem that is find the points on the curve y square is equal to 8x for which the abscissa and ordinate change at the same rate, right? So here we are given the equation of a curve which is a parabola, right? So this is the equation of a parabola, and here we have the standard curve, and this represent y square is equal to 8x, right? Now we have to find a point P on this curve whose coordinates are x comma y, and here we are given that the abscissa and the ordinate change at the same rate, right? Now see, the x coordinate is known as the abscissa, right? And the y coordinate is known as the ordinate. So here we are given that the rate of change of abscissa is equal to the rate of change of ordinate, right? And abscissa can be replaced by x and ordinate can be replaced by y. So we are given d by dt of x and d by dt of y, right? So the x coordinate and the y coordinate changes at the same rate, right? So let us differentiate this equation both sides with respect to t. So now we have d by dt of y square, and here we have d by dt of 8x, right? So now the derivative of y square with respect to t can be written as 2y, and here we have dy over dt, right? Because first we'll differentiate y square with respect to y, we'll get 2y, and then by chain rule we can write dy over dt. And here we have taking it outside the derivative sign, so we have dx over dt, right? Now see, dy over dt is equal to dx over dt. So we can now replace this dy over dt by dx over dt, and here we have 8 times dx over dt, right? So this term and this term get cancelled. We can also replace dx by dt by dy over dt, and then cancelling out dy over dt from both the sides. So now from this equation we have 2y is equal to 8. So y is equal to 4, right? Okay. Now taking this y is equal to 4 in this equation, we have 4 square is equal to 8x. So this is 16 is equal to 8x, and x is equal to 2, right? So we have the point 2 comma 4, right? So this point is 2 comma 4, for which the x coordinate changes with the same rate as y coordinate, right?